Hello everyone, we have another question on trig identities, that's trigonometric identities. The question reads, prove that sine 3 theta equals 3 sine theta minus 4 sine cube theta. Hence, find all values of theta for 0 degrees is less than or equals to theta, less than or equals to 360 degrees, which satisfies the equation sine 3 theta minus 2 sine theta. Okay, now to prove this identity, this is what we call triple angle formula. So to prove the identity, sine 3 theta equals to 3 sine theta minus 4 sine cube theta. Now the first thing we need to do is to what? Is to use what we call the sum to product formula. Okay, that is to express sine 3 theta as the sine of the sum of two angles. Okay, now we know that we can write 3 theta, okay, in expanded form as 2 theta plus theta. So which means, because we know that 2 theta plus theta is equals to 3 theta. So which means, first thing first, okay, now to prove, like I said, to prove the identity, sine 3 theta equals to 3 sine theta minus 4 sine cube theta. Okay, now like I said, we will use what we call sum to product. Okay, sum to product formula. Okay, it's one of the trig identities formula, okay, that we know. So which means, first we need to write sine 3 theta. Okay, we can write this as sine, okay, sine 2 theta plus theta. Okay, then we can now use what we call angle sum formula for sine. So applying angle sum formula for sine, applying angle sum formula for sine. Okay, so in this case we have sine 3 theta, which is same thing as what? Which is same thing as sine 2 theta plus theta. That will be sine 2 theta, okay, cos theta plus, okay, plus sine theta, okay, cos 2 theta. So this is the expanded form. That is when we expand this identity, that is sine 2 theta plus theta, it will be equal to sine 2 theta cos theta plus sine theta cos 2 theta, which is one of the, when we talk about sum and difference formula. So we have that of sine, cosine, tangent, and cotangent. Okay, so we have sine 3 theta equals to sine 2 theta plus theta equals to sine 2 theta cos theta plus sine theta cos 2 theta. Now remember, the identity we want to prove, that is sine 3 theta is equals to 3 sine theta minus 4 sine cube theta. So which means, now we need to express this in terms of what? Sine. So which means we need to first find the what? We need to find the double angle formula for sine 2 theta, and that of what? Cos 2 theta. Okay, so now also applying double angle formula for sine 2 theta and cos 2 theta. So we know that for sine 2 theta, the double angle formula is 2 sine theta cos theta. Okay, and for cos 2 theta, the double angle formula will be 1 negative 2 sine square theta. Don't forget that it is important for us to express this identity, now the identities, in terms of what? Sine. So which means we need to write this in terms of sine theta, that's cos 2 theta must be written in terms of sine. Okay, and also sine 2 theta, okay, we are also going to write this in terms of what? Sine as well. So, and for sine 2 theta, we have 2 sine theta cos theta. Then we also have cos 2 theta to be 1 minus 2 sine square theta. So we are going to substitute this into this equation, into this. Okay, now by substituting this, okay, these identities into the equation for sine 3 theta. What equation is that? That is, we have sine 3 theta to be equals to, we have that to be sine 2 theta cos theta, plus we also have cos 2 theta then sine theta. Okay, so now we know that sine 2 theta is what? 2 sine theta cos theta. So which means this will be 2 sine theta cos theta multiplied by cos theta, plus, now also we know that cos 2 theta is equals to 1 minus 2 sine square theta. So which means this will be 1 minus 2 sine square theta. Then also we have sine theta. Okay, so which means now after we substitute the double angle formula for sine 2 theta and cos 2 theta into this equation, okay, now then we need to distribute sine theta over the subtraction in this case, and we know that cos theta multiplied by cos theta is cos square theta. So this will be 2 sine theta cos square theta, plus this will be sine theta multiplied by 1, that will be sine theta, then 2 sine square theta multiplied by sine theta. Now sine theta multiplied by sine square theta, that will be sine cube theta. You know, when we have a to the power of 2 multiplied by a to the power of 1, that will be a to the power of 2 plus 1, and that will be a to the power of 3. Okay, that's one of the rules for exponents. Okay, so we apply one of the rules for exponents. Okay, now so sine theta multiplied by 1, why this will be 2 sine cube theta, 2 sine cube theta. Okay, so then also we have cos square theta in this case. So this cos square theta, we need to write it in terms of sine theta. Okay, and we know that one of the Pythagorean identities, because we have what we call Pythagorean identities. Okay, the Pythagorean identities, one of them is now using what we call Pythagorean identity. Using the Pythagorean identity, now we know that cos square theta plus sine square theta is equals to 1. So because we need to write cos square theta in terms of sine square theta, so which means cos square theta will be equals to 1 minus sine square theta. So we then again substitute 1 minus sine square theta for cos square theta in this case. So we have our sine 3 theta to be equals to 2 sine theta multiplied by 1 minus sine square theta plus sine theta minus 2 sine cube theta. Okay, now in this case we'll have to distribute 2 sine theta, okay, over this word subtraction, that is 1 minus sine square theta. So this will be 2 sine theta minus, now 2 sine theta multiplied by sine square theta. Remember, sine theta multiplied by sine square theta will be what? Sine cube theta. So that will be, because we have 2 sine theta, then this becomes 2 sine cube theta plus sine theta minus 2 sine cube theta. Okay, now when we combine these two, minus 2 sine cube theta minus 2 sine cube theta, that becomes negative 4 sine cube theta. Then 2 sine theta plus sine theta, that is 2 sine theta plus sine theta minus 2 sine cube theta minus 2 sine cube theta. So we can then say that sine 3 theta will be equals to, now 2 sine theta plus sine theta, that will be 3 sine theta. Then negative 2 sine cube theta minus 2 sine cube theta, that will be minus 4 sine cube theta. So we just prove that sine 3 theta is equals to 3 sine theta minus 4 sine cube theta. Remember, to prove this identity, the first thing we need to do is to what? To use what we call sum to product formula. Okay, sum to product formula. Okay, and that means we'll need to first express sine 3 theta as the sine of the sum of two angles. And we know that to write 3 theta, okay, another way to write 3 theta is what? Is when we write it as 2 theta plus theta. Okay, so now, and then we know that to obtain the identity for sine, we're going to make use of what we call angle sum formula for sine. So sine 3 theta equals to sine 2 theta plus theta, and that will be sine 2 theta cos theta plus sine theta cos 2 theta. And also, because we have double angle formula, we know that there are double angle formula for sine 2 theta and cos 2 theta, because our goal is for us to what? To express, to write this in terms of what? Sine. Okay, we change all the cosine into what? Sine. So when we but the only way to change cosine to sine is when we write the double angle formula for cos 2 theta and that of what? Sine 2 theta, which is what we have here. Applying double angle formula for sine 2 theta and cos 2 theta, and that will be 2 sine theta cos theta for sine 2 theta, and cos 2 theta will be 1 minus 2 sine square theta. So by substituting these identities into the equation for sine 3 theta, which is what we have here, okay, so sine 2 theta is 2 sine theta cos theta. Already we have cos theta, so that means 2 sine theta cos theta multiplied by cos theta. Then also we have cos 2 theta sine theta, and for cos 2 theta, the double angle formula for cos 2 theta in terms of sine will be 1 minus 2 sine square theta, 1 minus 2 sine square theta. So we then substitute 1 minus 2 sine square theta for cos 2 theta, then multiply by sine theta. So by the time we distribute sine theta in this case, we then have sine theta minus 2 sine cube theta, and then cos theta multiplied by cos theta, that will be cos square theta. Then again, we have to use what we call Pythagorean identity. Now we have about 7 Pythagorean identities. Okay, now one of them is cos square theta plus sine square theta equals to 1. Now then we can write cos square theta in terms of what? Sine square theta, and which will be cos square theta equals to 1. That is when we move sine square theta to the right hand side. Okay, we are going to have 1 minus sine square theta. So then this will now be substituted for cos square theta. Okay, and that is why we have this identity. Now the second question, hence find all values of theta for 0 degrees is less than or equals to theta less than or equals to 360 degrees, which satisfies equation sine 3 theta equals to 2 sine theta. Okay, now in this case, so this will be, let's say this is Roman numeral 1, this is Roman numeral 1, and why this will be Roman numeral 2. Okay, Roman numeral 2. Okay, so for Roman numeral 2, now we want to calculate now all values of theta, okay, all values of theta between 0 degrees and 360 degrees, okay, which satisfies the equation, we have we have sine 3 theta equals to 2 sine theta. Now, what we need to do in this case is for us to what? The first thing is for us to substitute this identity. That's the identity we prove will be substituted for sine 3 theta. You know, sine 3 theta is equals to sine theta minus 4 sine cube theta. So substitute the identity, the identity proven above. Okay, so we have this to replace sine 3 theta. So we have 3 sine theta minus 4 sine cube theta to be equals to 2 sine theta. So here we have 3 sine theta minus 4 sine cube theta to replace sine 3 theta. And on the right hand side we have 2 sine theta. All right, now we want to find all the values of theta. Okay, so to be able to calculate all the values for theta, so let's rearrange the equation. Now let me move this to the left hand side. So this will be 3 sine theta minus 2 sine theta, then minus 4 sine cube theta. This will be equals to 0. So 3 sine theta minus 2 sine theta will be what? Will be sine theta, then minus 4 sine cube theta equals to 0. So now we can solve for sine theta. So to solve for sine theta, now this is very important. Now, okay, to solve for sine theta in this case, so from there, we are going to move, let me rewrite this here. So we have sine theta equals to, so we have sine theta minus 4 sine cube theta to be equals to 0. Okay, now if we divide each of these by sine theta, we are going to have sine theta, okay, open bracket, 1 minus, that is sine theta divided by sine theta, that will be 1. 4 sine cube theta divided by what? Sine theta, that will be 4 sine squared theta. Okay, that equals to 0. That equals to 0. So we can say that this will be sine theta bracket 1 minus 4 sine squared theta, and that equals to 0. So which means that is, we are going to have, we can then say that, okay, the equation is satisfied if sine theta is equals to 0 or 1 minus sine squared theta is equals to 0. So which means we can say that if sine theta is equals to 0, okay, then we can say that theta, because the sine inverse of 0 will be now sine inverse of 0 will be 180, 360 and also 0. So which means, because sine 180 degrees is 0, then sine 360 degrees is also what? 0. So this will be the values of values of theta in this case will be 0 degrees, okay, 180 degrees and what? 360 degrees. So that's in the case of, now for the second one also we have 1 minus 4 sine squared theta to be equals to 0. Okay, so which means I'll move this to the right hand side so that 1 will be equals to 4 sine squared theta. Okay, then again I'll divide both sides by 4. So this will be 1 over 4 sine squared theta. Now to be able to calculate the value of theta in this case, so we have to take the square root of both sides. Okay, we take the square root of both sides. So by taking the square root of both sides, so this will be plus or minus the square root of 1 over 4 equals to the square root of sine theta raised to the power of 2. So this will what? Disappear. So this can now be sine theta equals to plus or minus 1/2. So which means we're going to get some values of theta in this case. So The first thing here is we know that sine theta is equals to plus 1 over 2, or sine theta is equals to minus 1 over 2. So when we now, in this case, the value of theta will be when we look for the arcsine of 1/2, and the arcsine of 1/2 will be 30 degrees, okay, and also the second quadrant will be 150 degrees. Yeah, 150 degrees. So these are the two possible values of theta when we have sine theta equals to 1/2. Then for the other one, we're going to have theta to be sine inverse of negative 1/2 minus 1 over 2. This will be in the that's for sine inverse of minus 1 over 2. That's going to be 330 and also 210. Yeah, so this will be 210 degrees and 330 degrees. So now remember, we are looking for all values of theta for 0 degrees less than or equals to theta less than or equals to 360 degrees. That is between 0 degrees and 360 degrees. So now we can then say that all values of theta between 0 degrees and 360 are, so we start from here. We have where are the values? So we start from here. We have theta equals to 0 degrees, okay, 180 degrees, 3. Now we have 0 degrees, okay, let's see, okay, we have 30 degrees, okay, 150 degrees, okay, 180 degrees. Then also we have 210 degrees, 330 degrees, and finally we have 360 degrees. So these are the values of the values of theta, which satisfies this equation: sine 3 theta equals to 2 sine theta. The noblest pleasure is the joy of understanding. Bye bye.